assignment is a two-part assignment. The first part is to build your initial energy model, which is going to be the baseline there. And then the second part is to do a sensitivity analysis looking at a whole bunch of other inputs. And you'll see these are very easy to change once you've got a baseline built. And that is going to be looking at what happens if you change your model and eliminate certain things. So for instance, what if you get rid of all people? Then theoretically your heating load would go up, your cooling load would go down, your ventilation rate might change, your lighting equipment process and hot water would pretty much stay the same. What happens if you get rid of lights? What happens if you get rid of equipment? And so on and so forth, on through different parameters. The idea of this exercise is that as you get rid of these different things, you're going to be able to see relative to this graph which are most important. Right now, this model, it's fairly clear that the heating, this large blue area, is predicted to be the most important. Whether we're looking at the benchmark building, the hand calc, or the baseline, they all show that the heating is substantial. And so a place to concentrate on. But relative to heating, it'll be interesting to see what things affect that. Does insulation affect that? Does ventilation affect that? Do the influx of internal heat loads affect that? Do schedules affect that? And so the goal of this exercise is not necessarily to have your baseline be exactly like your initial energy model or your utility bill. The goal is to be able to explain what's different about them and why, what assumptions are different in your baseline model than in these other models, and what are the parameters that your building is sensitive to, so that then you can go and try to devise a good way of renovating the building. So to help you do this, I've set up this input-output. Let me zoom out here. I've set this up in a graphic way so that as you input your baseline model here, and then for each successive sensitivity run, you'll change just one thing at a time and write down what that thing is. So for instance, right here, I've changed the lights to be 0 watts per square meter. So graphically, it's really easy to see that. And everything that's white, I've assumed to be the same as my baseline case. So I've still got 50 people, I've still got 25 watts per square meter for equipment, but now for lights, I've got 0 watts per square meter. And so every run, I'm changing something and changing it dramatically so that I can see what effect it will have. So this chart looks like a really large involved chart, but it's really just a graphic way of representing what you're changing. And most of all, it's for you to keep track of where you are in the bigger scheme of things as you go through, and you don't lose track of what you've input and where you still have to go.